something weird happens when we try to solve this difference equation. So let's just solve it the way that we did in the last video. So we can kind of build our way up in the terms. So this lowest order term will be a constant, then the next term up will be r, and then the highest order term, the tn, will be r squared, and we solve this to figure out what our roots are. So we can factor this, and we'll get r minus 2 times r minus 2 equals 0, which means that our answer is just r equals 2. So we only get one answer, but we might think, well, let's try the same method and see what happens. So you say that tn is equal to some number times 2 to the power of n plus some different number times 2 to the power of n, because we had the same root twice. So normally we take our two roots to the power of n and then multiply them by some constants, but now we have the same root twice. And let's just see what happens when we continue. So with t0 is going to be equal to 2, and that'll be equal to a plus b, and t1 will be equal to minus 1, which will be equal to 2a plus 2b, which is just by letting these equal to 1. But then we have a bit of a problem, because when we go to solve these, for example, we can multiply this equation by 2. That means that 4 is equal to 2a plus 2b, and this one means that minus 1 equals 2a plus 2b. But that means if these 2a plus 2b is equal to both of these things, does that mean that 4 is equal to minus 1? Well, clearly not. The reason that this happens is because remember how I said that we need two parameters in order for these to work. Because remember in the last video, when we guessed that the solution, so this is a little aside, when we guessed that the solution was some number times a root to the power of n, just like this, we weren't able to get a solution because we had two kind of starting conditions, but we only had one unknown that we could solve for. So when we tried to make both of these conditions be true, we ran into a contradiction where we solved for a with t0, then we got a value for a, but then it didn't agree with t1, which is why we needed the two terms with the two different constants. However, the problem with this, I'm just going to get rid of this part because we know that it doesn't work, is we can actually factor out a 2 to the power of n here, and we get that tn is equal to a plus b times 2 to the power of n. So you can actually see here that this is the exact same as writing tn is equal to a times 2 to the power of n, because a plus b is just a number, so this is just kind of like having one term. So that's the reason it doesn't work. It's like the reason that it didn't work in the last video. So what can we do to fix this? Well, there is a motivation for this. It'll be in the extra videos. But what you might think is, okay, well, what solution? We know that each of these individually are solutions. Maybe we could tinker with one of these solutions and slightly change it, and then it'll work. So I think the most simple thing you could do to tinker with one of the solutions is we'll keep the first one the same, but for the second one, we're going to add in an extra. We're going to multiply by n. So I'll have n times b times 2 to the power of n. And again, in the extra videos, I'll motivate why we'd try putting an n there. But for now, this is what we're going to try. And let's just see what happens. So this is what, we're not going to try this solution. Doesn't work. We're going to try this solution. And if you want, you can sub this into the original. So take this and sub it into this original difference equation. And you'll see that it actually is valid. When you sub this into the original, it'll completely, both sides will be equal. So we know it's a solution. So you can guarantee that. And let's just see that a and b are equal. Or what a and b are, sorry. So if we go for t0 will be equal to 2, which will be equal to a plus. And then here's the interesting thing, because here we're going to have 0 multiplied by this stuff. So this entire term becomes 0. So it's actually a little easier that 2 is equal to a. Cool. Then t1 will be equal to, and again, that's because n was equal to 0. t1 is minus 1. Which will be equal to a times 2 to the power of n. Well, we know that a is equal to 2, so we can say 2 times 2 to the power of n, plus, and now n is 1, so we'll have 1 times b times 2. Or sorry, 2 to the power of n here, that should just be 1, n is 1. So this is the equation we get, subbing in n equals 1. Then we'll get minus 1 equals 4 plus 2b, so bring the 4 to the other side, minus 5 is 2b, so b is equal to minus 5 over 2. So then finally, we can write our final solution down here. So we can say that tn will be equal to, and we're going to have a times 2 to the power of n, so 2 times 2 to the n, plus n times b. So I'll actually write this as minus 5 over 2 n. So again, n multiplied by b, I'm just writing that as minus 5 over 2n to make it easier, multiplied by 2 to the power of n. You don't have to, but you could clean this up if you'd like. So you have to write less into your calculator. That's because 2 times 2 to the n, that's the same as 2 to the n plus 1. And then you could also say plus, and it's going to be 2 to the n minus 1. Or alternatively, you could factor out 2 to the n, whatever you want. I'm just going to do it like this. So I'm going to say, instead of plus minus 5 over 2, I'm going to say it's going to be minus 5n times 2 to the power of n minus 1. So yeah, that's how we can clean it up. Just combine that 2 with that, and then instead of saying plus minus 5, I said minus 5n. So here's our solution. Again, you can plug in 0, plug in 1, and you will see that you get the correct answers for t0 and t1, and you could use the difference equation to find t3, t4, t5, and you'd see that this will give you the same answers. So yeah, there might have been some questions in the previous video that you weren't able to do, so this should enable you to do them. But yeah, other than that, there's no extra questions. This is just like a special case of the last video.